So this week we're looking at lists. The Python list is an amazing data structure, and it's important to note that there really isn't an equivalent data structure like the Python list in other languages. There are other similar data structures. In Java, you have arrays. You could use the ArrayList class. There's some other data structures. Arrays are much more standard and much more limited than the Python list. The Python list is pretty amazing. So to create a Python list, there's a bunch of different ways we can do it, but one way is we can use square bracket notation and we can just add data inside of the list. And the Python list is so amazing that we can mix data structures. So I could have dog, and I can have an integer, I could have a string, I can have a float, and I can put a boolean all in one list. I can also actually put a list within a list. So I could actually have list 2, and I could actually have a list of some different things here, and then I could have 7.2 and false. So I can put any data that I want, including other lists. Each element is separated by a comma. So this is the first element of the list, and just like strings, we index. So this is element 0. This string dog is at element 1. The whole string is at element 1. This float is at element 2, and this boolean here is at element 3. This whole list here is at element 0 of list 2. This float right here is at element 1, and this boolean is at element 2. Now, to go further, you can actually index into the elements in the list. So this string here is at element 1 in the list. So let's say I did something like print list 1 sub 1. So that gets us to dog. If I were to just print this, it would print dog. But dog itself is indexable. This is also it's a string. So the D is at index 1, the 0 is at index 2, or index 0, 1, and the G is at index 2. So if I were to actually do print list 1 sub 1, when I print this, you're actually going to get the letter O. So I like to think of lists as kind of like apartment buildings, and then each of these is an apartment. So the whole apartment building is list 1, and at apartment 0 you have the 6. And here at index 1, maybe you can think of this as having multiple rooms. So maybe this is like in an office space in this apartment complex, and then there are different offices, office 0 or bedroom 0, office 1, bedroom 1, however you want to think of it. But you can index into that, and we could actually do this indefinitely. So in here, over on list 2, this is at index 0, but within this list, let's see, I have the number 1, this is at index 0, and I have cat is at index 1, but then this string is also indexable 0, 1, 2. So if I printed list 2 sub 0, so that gets us to this list right here. Sub 1 actually gets us to this string that is at element 1 inside of this inner list. And let's say I print at index 1 of the string, this will actually print the letter A. So you don't have to take my word for it. Oh, and let me put a parentheses there. Let's actually take a look at this in idle. All right, so let's say, and I'll just go ahead and open a new file. We could probably just do this in the shell, but let's just do what we're used to here. 2019, and we're gonna have some fun with lists. Oops. All right, so let's say I have my list 1 is going to be equal to, I've got 1, 5, ice cream, true. All right, so here's my first list, and then I've got list 2, and I'm going to put maybe 6, and then I'm going to put another list in here, and maybe this is cat, 25, false, and and then maybe we've got another false here. All right, so now we can index into some of these places or some of these lists and see actually how we can retrieve different elements of this list. So if I just print list 1 sub 2, what I should get is element 2. So 0, 1, 2. So this should just print ice cream for me. So let's see if it does. Let's see. Oh, incorrect syntax here. It's early. Here we go. There we go. So we got ice cream. So for list 1, this is element 0. This integer is element 1, and this is element 2. If I print element 3, this should get us true. And it does. All right, so now let's try actually indexing into this string as still an element of this list. So to access, so maybe I want, let's see, so we're going to go index 2, and let's say I actually want to get a slice of this. So let's go from 0 to, and I want to catch this E, so 0, 1, 2, so let's go to 3, and this should actually print ice for us. So I'm grabbing from list 1 the element at index 2, that's ice cream, and then I'm actually going to index into that because this right here returns that whole string, ice cream. So I can actually also slice or index into this, the returned string, from using indexing on the list. So this should print ice, and it does. Similarly, down in list 2, I could also index into this list here. So this is at index 1. The entire list is at index 1. And now to actually get cat, I can grab what's at index 1 of list 2, which is this entire list, and then what is at index 0 of the return from grabbing list 2 index 1. So this should actually return us cat. And if I want to get, say, the letter A, then I can just further index and grab it at index 1. A. So here I'm just, you could again just think of this as addresses. So I'm going to grab the variable list2, and I'm going to get first what is in index 1 of that entire list. So looking at this entire list, this 6 is at index 0, this whole list is at index 1, and this Boolean is at index 2. So once I've grabbed this right here at index 1, then I'm interested in what is in whatever is in here at index 0. And in this case, it's the entire string cat. So this whole thing returns cat. So then I'm going to index into that string, that cat string, and at index 1, I'm going to get the letter A. So this whole thing is going to get me the letter A. So we can have lists of lists. We're going to learn about dictionaries. We can actually have lists of dictionaries. You can have a list in a dictionary, only not as the key, just as the value. There's lots of cool things that we can do with lists, we can use indexing and slicing. So here, if I did from index 0 to index 2, this should get me CA. Let's see if it does, and it does. Right, so we can use indexing and slicing with lists and strings. It's something you're going to want to get some practice with to make sure that you understand how it works. We use nested lists quite a bit in programming. Lists are an incredibly useful data structure in Python for holding data for us, groups of data, and there is an equivalent in other languages called arrays, although they're usually more limited. But so here's sort of your first taste of a data structure more complicated than strings, and Python lists are really cool. So Python lists are mutable, where Python strings are immutable. And let me show you what this means. So if I have something like string 1 is equal to bog, and I have list 1 is equal to, let's say I've got a dog, a cat, and peanut. That's a square bracket. All right, so let's say within this string, I need to change this. What I meant to do was make this dog. It is not legal in Python for me to say string sub 0 equals a D. This will give me a syntax error because strings are immutable. I can't actually change any piece of this. I'd actually have to build a new string. So I can say string 1 equals dog, or I could loop through it and check anywhere I find a B, I could change that to a D, or I could check, if string 1 sub 0 equals B, then, let's just change the whole string 1 to equal dog, or I can say string 1 or maybe new string is equal to D, and then add the rest of this string, as a slice from 1 on, something like that. But either way, if I have to make a change, I have to build a new string somehow. I can use the same variable, I can use a new variable, but strings are immutable. I have to make a new string completely. I can't just change a single element. Whereas in lists, I can change a single element. So let's say I'm like, oh wait, dog, cat, peanut. No, I don't want peanut. It is totally legal for me to do something like list 1 sub 2, 0, 1, 2 is equal to rat, right? And then if I were to print this list, it's going to say dog, cat, and rat. So I can change elements of lists like this. This is totally legal. Python likes this. This is fine. Python does not like this. This is not fine. So this is what we mean by immutable and mutable. So strings are immutable. I can't change a piece of it. I have to change the whole thing. Lists are mutable. It is totally legal for me to change a single element of a list. So because we can index lists, we can also process them with for loops, just like we did with strings. One of the things we can do with a for loop with a list is actually print it out. Now, Python will let us print the list directly, so I can do something like this, print list 1, but it's going to ugly print it. So what I mean by that is that when you print it out, it's going to include all this stuff. So it's actually going to have, the square brackets, it's going to have the commas, it's going to have quotes, and all that kind of stuff with it. Doesn't look very nice, and actually in other languages, all you would get if you did something like this is the hexadecimal memory address as to where this list is actually located. So you wouldn't actually be able to see the information inside the list, you would just be able to see where it's located in RAM, which may not be what you want. So in other languages, and then also to make a list print nicely in Python, we can use a for loop. So we can do something like for I in range, from 0 again we'll use the length function just like we did with a string, length of list. We can just say print list 1 sub I, and we could let it go to the next line, or if we just want to see it on the same line, we can of course use our little end parameter and be able to see our list maybe a little more nicely. And maybe we still want commas in between them. We just maybe don't want the square brackets and whatnot. So here we go. So this looks a little bit nicer. So here's the ugly print. It's got square brackets. It's going to show you, oh, look, I'm a string. And here, this looks just a little bit nicer. And this is really what you have to do in many other languages because they won't let you use the print function. So of course, there's lots of other things that we can do with for loops. So let's get rid of this so it doesn't print every time. So as I mentioned before, lists are mutable, right? So let's say we want to change this number to 26. We can do something like let's say we need to search through it. We know somewhere in here is the 25 and we want to be able to change it. Well, actually, we would have to use a nested loop for this. So let's try this one first, the simpler one. All right, so we know somewhere in here there's a 5, and we know wherever that 5 is, we actually want to change it to be 15. So we can go through this list and we can say if list 1 sub I is equal to 5, then list 1 sub I, we're going to set that equal to 15. And then when we're done, we can just ugly print it. All right, so we'll just see what's in here once we print it. Run. There we go. So now we actually changed that 5 to 15. So, again, we can use a for loop to go through a list, look at the different elements each time, and, if there's things we need to do with the list, if we need to print them, if we need to search for different things, it's pretty handy. One of the things to note is that if you have a list inside your list, or let's say we want to change something inside of this, we would have to use a nested loop. So let's say we're actually looking at each element, or we want to be able to find, and it's actually going to fail because we can't iterate through these. So let's make us another list. So we're going to have a list of just strings. I'll show you what I mean. So I've got dog, I've got cat, and I've got rat. And let's say everywhere that there is an a lowercase a, let's say we just want to turn that into an uppercase A. So we're going to loop through this outer list here. So we're going to loop through this outer list, but then we actually need to loop through each of these as well. So we're going to say for j in range from 0, and this time it's going to be the length of list 3 sub I, because if I have, in this case, these are all 3, but let's say I also have rabbit, then I want to make sure, that I go 3 here, 3 here, 3 here, but 6 here. So in this case, this is actually looking at each element. So list 3 sub I, the first time through, list 3 sub 0 is dog. It's the whole string of dog. The second time through, it is cat. Then it's rat, and then the last times through, it's rabbit. And so we actually want the length of each of those strings, and to get the address of those strings, it's actually, in that list at the ith element. So in this case, so now we're looking at j. So j is our counter, and now j is going to be each of these letters. So when I'm looping through this, so the first time we're going to hit I. So for I, we're looping through the whole list here. So the first time I is 0, and then list 3 sub I is dog. The second time I is 1, and list 3 sub I is cat. The next time through this outer list, list 3 I is 2, so list 3 sub I is rat. We're taking a look at rat. And then the next time through, it's rabbit. Each time through this list, now we're looking at this element. So j is actually refers to the index of the string itself. We're looking at list 3 sub I, and the j, so when we're going through this first time of the loop, j is going to refer to dog. So j is going to be 0, then 1, then 2 as we loop through dog. Then we're finished, and we're going to go back up, and then we're going to look at cat. And now j refers to 0, 1, 2. Finished, go back up. Now we're looking at rat, and so j refers to, so I refers to this whole element, and j refers to the r, then the a, then the t. Well, really 0, 1, and 2. The next time through, we're looking at the third index 3, the fourth element, and so this time j is actually counting through 0, 1, 2, 3, 4, 5. All right, so to show you what I mean, let's just actually print list, list sub I, sub j. So this will actually print each and every letter of each string. So the first time through, and let's see, we'll say here print end inner loop, so that you can actually see it's going to go through this outer loop is going to go, and then this inner loop is going to run 3 times, print the letters of dog, then the inner loop ends. We're going to come back up and let's put in here print start inner loop, and let's put up here print start outer loop, right? Print end outer loop. Now you should see this should print a total of 4 times. This should print a total of 4 times because this loop is going to go 4 times. We have 1, 2, 3, 4 elements in this list. We're looping from the 0th index to 1 before the length of the list. This loop here, however, is going to actually run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times, because for the first time this loop runs, the inner loop goes 3 times. For the second time this outer loop runs, the inner loop runs 3 times. The third time the outer loop runs, inner loop runs 3 times, and then the fourth time the outer loop runs, the inner loop is going to run 6 times. So let's see what this looks like. I have a syntax error. List 3. Go. Oh, and we don't need to worry about that because we're not really modifying anything. We're just printing. So here we go. All right. We started the outer loop, started the inner loop, printed the D, ended the inner loop, started the inner loop, O, end the inner loop, started the inner loop, G, and the outer loop here. So this all right here was the first time the outer loop ran. The inner loop ran 1, 2, 3 times. Right here, this is the second time the outer loop ran. The inner loop ran 3 times. Here is the third time the outer loop ran. The inner loop ran 3 times. And here is the last time the outer loop ran, and the inner loop ran 1, 2, 3, 4, 5, 6 times. Nested loops are pretty important. You can use them for a lot of different things, and we'll see a lot of different examples as we go through our practice. So you can also have lists of lists, and these are also handled with a nested for loop. We can have lists of strings, we can have lists with different data types, and we'll do, quite a bit of practice with these. Just like strings, we also have some built-in methods with lists, not as many as with strings, but we do have that you can insert an item at a given place. So you're going to give the item I, and the X is going to be the position you want to insert it at. The dot remove is pretty handy. You give it a like an item that you want to remove. So in our list of cat, dog, rat, rabbit, if you wanted to remove rat, you would just say list.remove rat in quotes, and it should remove that from the list. If there is no items, there's no such item, let's say you tried to remove a horse, it would give you a value error. Pop is really handy. Now, normally the pop function works by removing the last item in the list. So if you don't specify an index, then it's just going to remove and return the last item in the list. If you give it an index, then you can actually pop from inside of the list. You should know that pop doesn't actually usually work that way in other programming languages. Pop is just mostly used as popping something off the end of a list, so or end of a data structure. You can clear, you can remove all of the items in the list. You can use .index, which is kind of like find. So you're going to say what you want to look for and where you want to look for it in the list, and it's going to return the index of the first place where it finds that item. We can count the number of times a specific value appears in a list. So maybe you have a list of a lot of numbers. You want to know how many times 1999 appears. Count is pretty handy. The .sort functions will sort the list in place, and you can also reverse the list or copy. So some of these you'll actually be asked to write yourself in practice. So it's really good practice for you, for instance, to write your own version of the reverse function, something that would reverse the elements of a list using a for loop that counts backwards. So this is a good way if you're looking for some more practice. Instead of using built-in functions, you can actually try to write your own version of a list function or a string function, and those are almost always going to involve for loops. So have a good time getting some practice with lists, and let me know if you need any help, and have fun.